Okay, students, taking off from where I left in the last session, I stopped at AP, right? Then arithmetic progression. Uh, Let me just go to the next part of our AP itself. I'm just doing a quick recap. Yeah. So we just kind of scan through all the chapters. Now, sum of n terms. We saw a lot of things about AP. Yes, one more thing. If three terms A, B, C are in AP, I told you that B is equal to A plus C by 2. This you can get problems on this. Maybe in MCQs you can get. So do keep a note of that. And sum of n terms. So when we have an AP like A1, A2, A3, and there are, let's say, some AN, let's say there are n terms. The last term is AN and there are n terms in the AP. Yeah. So the common difference is D is A2 minus A1, right? Any term, or D is A3 minus A2. Any term minus its predecessor will give me the common difference. So knowing this, knowing N, knowing D, knowing the first term A, I can calculate the sum of the n terms. That is, if I'm going to add all the terms in the AP all the way up to AN, what will be the sum? The sum is Sn, sum of n terms, right? So Sn is equal to n by 2, this formula, into 2A plus n minus 1 into D. Sn is equal to n by 2 into 2A plus n minus n by 2 into 2A plus n minus 1 into D. Okay, this is the formula. Suppose in the AP, I tell you what is the last term. Okay, A1 plus A2. I'm adding n terms, right? There are n terms. And suppose I know the last term, that is AN, or that is L. I told you the last term is in a finite AP is denoted by L, right? There are n terms. So L is nothing but AN. L is AN. Just like A1 is A, right? So the L is the last term in this case, or how many ever terms I'm going to consider in that set. The AP might be consisting of many terms, but if I'm going to consider the first 10 terms, let's say, and the 10th term will be the last term. So if I know the last term, and if I know the number of terms, if I know A, I need not even know D, I can calculate Sn is n by 2 into A plus L. So this is another formula, provided I know the last term in the for the AP arithmetic progression in the series. Okay, with this I'll go on to the next one, which is remainder and factor theorem. So f of x is a function of x is, let's say, 2x square minus 5x minus, I'm just taking one example out here. So it's a function of the variable x. This, as in to say that this expression, the value of this expression depends on x, isn't it? Depends on x. So if I put f of 3, that is when x is 3, this will become 2 into 3 square minus 5 into 3 plus 7. What will it be? 2 into 9 minus 15 plus 7. 18 minus 15, that is 3 plus 16, which is 19. Then what is f of 1? So 2 into 1 square minus 5 into 1 minus 7. That's 2 minus 5 minus 7, which is 2 minus 12, which is negative 10. So you see, depending on the values that I assign to x, the function also gets different values. Expression gets different values. So it's depending on x. Okay. So now I'll just show you one division here and then take you to the remainder theorem. You are all familiar with it. I'm just giving you a recap here. With exam being tomorrow, we are not going to solve anything new. It's just that I'm just giving you a recap. Those of you are preparing on these grounds, x square minus 5x plus 9. See, I'll do long division. Okay, I'm just going to do the long division. Just change the color here. Okay, x into x is x square, long division, minus 2x. Change the signs and you get minus 5 plus 2 is minus 3x, isn't it? Plus 9, bring it down. X into minus 3 is, this is just long division, which is kind of, all of you are familiar with this. You subtract, you're going to get 3. So now I'm interested in this remainder 3. 3, it's a constant, right? And the divisor is x minus 2. It's a linear polynomial. Constant polynomial, the degree is 0. So we stop at this process. So why I'm interested in 3? The remainder is 3. Yeah. So what did I do? I divided x square minus 5x plus 9. I have divided it by x minus 2. The remainder is 3. Now what I'll do is, the same function f of x, right? The function, my dividend in this case, I'm going to find the value of the dividend when x is 2. F of 2 I'll find out. So I'll get 2 square minus 5 into 2 plus 9. 4, 5 2s are 10 plus 9, 13 minus 10, which is 3. And this is going to hold good. So remember, this is always going to hold good. So when you divide f of x, when it is divided by x minus a, the remainder, it leaves the remainder, right? If at all it leaves. The remainder is f of a. This is your remainder theorem. And in factor theorem, what do we see? See, in the previous case, there is a remainder 3, isn't it? It's not 0. If the remainder is 0, if f of a is 0, because the factor theorem is just a consequence of this. If f of a is 0, that means x minus a is a factor of f of x. Because f of a, that means remainder is 0. It's simple, right? 3 is a factor of 12 because 3 4s are 12. And if 3 is not a factor of 11, 3 3s are 9, it's going to leave a remainder. If it's not leaving a remainder, it's a factor. Simple as that. It's the same thing. So when we are asked, let's say for a 1 mark under MCQ, when you're not supposed to do long division, not expected to do long division, I would say, then you can directly use remainder theorem. It is simple. F of x is divided by x minus a. The remainder is f of a. Okay. So, and then factor theorem is, if f of a is 0, remainder is 0. And hence that x minus a, whatever I'm dividing it by, the divisor becomes a factor. For example, you can, suppose I'm asking you, like, f of x is equal to x cube plus 3x square minus 12x plus 4. Okay. So this is my function. I'm dividing it by x minus 2. Divide by x minus 2. And you use remainder theorem to verify. So, yeah, I'll do the long division itself. X cube plus 3x square minus 12x plus 4. So what will I get here? X into x square is x cube minus 2x square. You change the sign. 5x square and bring this down minus 12x. So x square then plus 5x, isn't it? So it gives you 5x square minus 10x, and then you again change the signs. So you get minus 2x and you bring down plus 4. X minus 2 is minus 2x plus 4, and then remainder is 0. So remainder is 0. Okay. So then let me find out what is f of 2. F of x is divided by x minus a. A is 2 here, isn't it? So f of 2, what do I get here? See, I'm dividing x minus a, dividing f of x by x minus a is 2, right? So f of 2, I'm going to find out. So f of 2 is 2 cube plus 3 into 2 square minus 12 into 2 plus 4. So that will be 8 plus 3 into 4 minus 24 plus 4. 8 plus 12 is how much? 20, no? 20 minus 4, 24 plus 4. 24 minus 4 is 0. Yeah, you're getting that. So in this case, you're dividing f of x by x minus 2. The remainder is 0. And you can also verify it by the remainder theorem, and long division also is there. Both I have done here. So this part I've done here is remainder theorem. Okay. And what does it what do you infer from this? Because remainder is 0, x minus 2 is a factor of f of x. Okay. Now so what have I done? Just going back to this, see. So it's like x cube plus 3x square minus 12x plus 4. I am dividing it by what? I'm dividing it by, okay. I'm dividing it by x minus 2. Okay. X cube plus 3x square minus 12x plus 4. I'm dividing it by x minus 2. And I got this polynomial on top. We did the long division in the previous page, right? X square plus 5x minus 2. Now, why am I so interested in this? I'll tell you. It's like, I need to know the other factors. See, it's like if I give you the number 30, for example, the prime factors of 30 are 2, 3, and 5. Let's say I don't know this. Let's say I know that only 2 is a factor of 30. I'm just giving an analogy here. 2 15s are 30, right? So remainder is 0. So 15 when decomposed will give me 5 and 3. The quotient is decomposed. So the same thing. So in the case of the polynomial, if you see here, I'm dividing this by this. I'm going to get the quotient, right? I'll decompose this quotient. I'm going to decompose this quotient into two parts and get two other factors. It's a quadratic, right? I can break it up into two linear factors. So we'll do that. So x square plus 5x minus 2. What do you get? If you are going to split the middle term, x square plus 5x minus 2, we can decompose further and get this value. Whatever, if in this case it's not possible, so we can write it as x square plus 5x minus 2 into x minus 2. So when I multiply these two, I'm going to get, I'll give you another example. I'll show you the decomposition. In this case, it is not possible. I'll just show you this, okay? So what I'm trying to say is, these two, when you multiply, you're going to get this cubic, the quadratic and this linear. Okay. I'll take another example. So I'll try to tell you what I'm trying to exactly say in this example. Okay. So this is where we, sometimes they say factorize completely. Factorize this polynomial completely. That's when you have to use this. So let us say that we have 5x cube plus, 5x square plus 15x minus 50. This is straightforward because I can see by intuition, or we say what, by inspection, we can find out one root. So x minus 2 into 5x is 5x square minus 10x. So minus and plus, we get 25x minus 50. So x plus 25 is, wait, I'll just write it here. So x plus, I'll just erase this. So x plus 25 is 25x minus 50, and remainder will be 0. So we got two things, right? So we got x minus 2 into 5x plus 25, which will give me the dividend f of x, that is 5x square plus 15x minus 50. This, of course, I can decompose again, isn't it? Into 5 common into x plus 5. So will give me this. So in other words, I can say 5 into x minus 2 into x plus 5. When I multiply suitably, I am going to get this. So this is one such example. I'll just give you an example. So let's say f of x is, let's say, 3x cube plus 2x square minus 19x plus 6, okay? And the problem may be like this. Using remainder theorem, factorize completely the polynomial. So you can do f of 1, which is 3 into 1 cube plus 2 into 1 square minus 19 into 1 plus 6. It's always good to start off with numbers like 1 minus 1, 2 minus 2, 3. You'll get the value in any of this. I mean to say one of them will be a factor. So I'm just doing this so that I get what? 3 plus 2 minus 19 plus 6. So 3 plus 2, 5 plus 6, 11 minus 19 is some value which is not equal to 0, whatever. So you cannot, it means if f of 1 is not 0, f of 1 is not 0, so x minus 1 is not a factor. Okay, it is simple as that. So you can check for, see, f of minus 1. So f of minus 1, let's check. F of minus 1 will be 3 into minus 1 cube plus 2 into minus 1 square minus 19 into minus 1 plus 6. So 3 in minus 3, 3 minus 1 cube is minus 3, minus 1 square is plus 1, no? So plus 2 plus 19 plus 6. So if you go here, 19 plus 6 is 25, 27 minus 3. Again, it is not 0. Whatever, it's going to have some finite non-zero value. So f of minus 1 is not equal to 0. So it's f of minus 1 is not equal to 0 means x minus of minus 1, which is plus 1, not a factor. So then I told you we can go with 2. We will check with 2. Wait, the same question. So f of x, I'm rewriting that here. What is it? 3x cube plus 2x square. So you will get it. This sum I've just shown you where, with f of 1 is not 0, f of minus 1 is not 0. So x minus 1 is not a factor, x plus 1 is also not a factor. Okay, 3x cube. So f of 2, we'll see what happens. 3 into 2 cube is 8. I'm doing it directly. 2 into 2 square is 4. So wherever there is x, I'm putting 2. Minus 19 to the 38 plus 6. So let's see. 8 3s are 24 plus 4 2s are 8 minus 38 plus 6. So yeah, 8 plus 6 is 14. So 24 plus 14 will give me 38, right? Yeah, it is 0. So f of 2 is 0. Since f of 2 is 0, it means what? X minus 2 is a factor. So now the next thing is I have to decompose this further. So x minus 2 is a factor. So you'll be getting 3x cube plus 2x square minus 19x plus 6. It's like the case of 30, right? I took 2 as a factor. 2 15s are 30. And now I'm decomposing 15, right? So 15 will give me 3 and 5. So I'm getting the other factor. Same thing. So x into 3x square will give me 3x cube minus 6x square. I can even use simple synthetic division. I'll show you that. So this is what 8x square I get, right? Minus 19x plus, we'll take the 6 down later. We'll just stop at this. So yeah, x plus 8x is 8x square minus 16x. So when you subtract and change the signs, minus 3x plus 6, you're bringing the 6 down. X into minus 3 is minus 3x plus 6 and of course 0. So you're getting this quadratic, right? Just like how you got 15 as the case of 30, the quotient. So how you get 15 here, no? Same thing, you got 15, no? And you're going to decompose it. Same thing, you're getting this quotient. You can decompose it. So 3x square plus 8x minus 3 is putting the middle term. So yeah, 3x square plus 9x minus 1x minus 3. So you can take out 3x into x plus 3 minus 1 is common here into x plus 3. So we get x plus 3 into 3x minus 1. These are the other factors. So it's like x minus 2 and into quotient, right? Will give me the function. So f of x is x minus 2 into the quotient. And the quotient is 3x square plus 8x minus 3. And I have decomposed that as, by using putting the middle term as x plus 3 into 3x minus 1. I'll do that here. I'll write the x plus 3 into 3x minus 1. When I multiply all this, I'll get the polynomial. It's like 30 is equal to 2 into 5 into 3. The same logic here. So f of x is this polynomial, which is that 3x cube. We have decomposed it completely. I mean to say we have factorized it completely. Minus 19x plus 6. Okay. So this is one way of doing. In synthetic division, what you do is, see, when I divide, I have 3x cube plus 2x square minus 19x plus 6. That is f of x, right? I did the division process and I got yeah, when I divided by x minus 2, what did I get? Dividing this by x minus 2, I got the quotient as I got x minus 2 as a factor, isn't it? So because I found f of 2 is 0 in this case. So what you can do is synthetic division, I list them out. I just list the coefficients 3, 2, minus 19 and 6 and see what happens. So the first, I just put a 0 here and I add them. Okay, 3 plus 0 is 3. Now you multiply. So I wrote 3 plus 0 is 3. 3 2s are 6. Yeah. So 6 is here. And then you add. You're basically adding here. 6 plus 2 is 8. And then multiply. You got it? So this is multiplication here. So 2 into 8. 2 into 8 is 16. Minus 19 plus 3. 16 is 3. And then I get minus 3. 2 into minus 3 is minus 6. So you see I'm diagonally what I'm doing. 3 plus 0, 3. 2 into 3, 6. Take it forward. Next, you add, you get 8. So 2 into 8 is 16. Take it up. Minus 19 plus 16 minus 3. And 2 into minus 3 is minus 6. And you stop here. Okay. You started off with a cubic, isn't it? And you start off with a cubic and you end with a, so this will be corresponding to the coefficient of x square. Remember this. So you get 3x square plus 8x minus 3. So this is what you'll get. You're dividing the cubic by linear. Remember, x cube by x is x square, isn't it? So simple logic. So cubic by linear, you're going to get a quadratic. And that we can decompose further by any of the techniques. Or you can use Sridharacharya's formula, or you can. So this is how it is. This is what it is about as far as splitting the middle term is concerned. Or you use synthetic division, or you can use your general factorization. That is splitting the middle term. But yeah, for that you need to know one root, isn't it? For that you will be using x is 1, minus 1, 2, minus 2, 3. So you don't have to go really far. In this pool itself, you'll be able to find factors. Even the question that they give you will be of that. They won't give you something totally different. I mean, they'll not give very complex polynomials, I'm trying to say. So I think up till here it's clear. I'll just go on, and in the next session, I'll just do a little of matrices.